welcome to QLab. I know it's been a bit of a while, but in today's video we're going to be picking up some of the calcium stuff we've done before. So we're going to take some of that calcium acetate we made when we were reacting eggshells with acetic acid, and we're going to see what happens when we heat it up a lot. And we'll be using the very scientific technique of a barbecue. Let's get started! So in this little crucible I've got some of my calcium acetate, and I'm going to make use of a barbecue to turn it into calcium carbonate or calcium oxide. Now I'm not sure it's going to get hot enough. The wood certainly won't. It'll burn at about 400 degrees Celsius. But the charcoal, now that can burn a lot hotter. It can burn up to over 1,000 degrees Celsius, but it's got a lot of mixed things in ordinary charcoal, and also I won't be blowing lots of air through it, so it won't burn very efficiently. But let's get this going, and I'll get the crucible in there. The fire's going nicely now, so I'm going to attempt to pop in the crucible in one of the corners. Well, there it's burning beautifully, and I've got the little crucible in the corner, so I'll leave it in there now. I am going to cook over this barbecue, and then we'll have a look at it once everything's died down. Right, well there it is. I moved it into the middle. It's all done now, so let's take it inside and have a look at it. So here we have the crucible that came out of the barbecue. So let's have a look at what we've got inside there. Well, we have a look at this. We can see that there's a very sort of light greyish powder. It seems very fine, very similar to what we put in, except grey rather than white. Now let's have a little think about the properties of what we might expect to see in here. Now, we could lose the acetate from the calcium acetate and maybe get something like calcium carbonate, but that would be white. So calcium carbonate's white. Remember, with chemistry we always think about the properties of things, and that's how we determine whether we've made something new or what we have made. So I know that we had calcium acetate go into this reaction mixture, and so we could have got calcium carbonate or calcium oxide, both of which are white. So why is this grey? Well, I can think of two reasons. One, the calcium acetate wasn't really super pure, and it would have had things that contained carbon in it, probably a bit of proteiny mess and gunk. And when it heated up, well, that would have tried to burn, but because the lid was on, it wouldn't have burnt very well or combusted very well. And so we'll have ended up with carbon deposits, which would have been little black specks, which in a white mixture, of course, will make it look grey. The other thing is that as the calcium acetate heats up, it gives off acetone, which would also just want to burn if there was lots of oxygen present. But because the lid was on, it maybe didn't burn very well, and that would also lead to some carbon deposits, which of course would be black. So we've got white stuff and black stuff all mixing together to get grey stuff. Thrilling science. So, how do I know anything's changed? Well, we're going to have a think about the properties again. The calcium acetate we have, we know that that was soluble in water. And in fact, let's have a little look at some of the calcium acetate from last time, because I kept some back. So there's our calcium acetate. Let's just remove the lid so we can see things clearly. Now the calcium acetate was soluble in water because of how we cleaned things up. So if this was still had lots of calcium acetate in, we'd expect it to be soluble in water. Whereas the calcium carbonate, like the eggshells, weren't soluble in water, were they? Otherwise, when you boil an egg, the shell would dissolve. So that's not soluble in water. Calcium oxide, on the other hand, reacts with water to form calcium hydroxide, which is a base. So what we can do is we can add a bit of this to some water. Let's do that right now. Here's some water. Ooh, is it going to focus? It's not going to mess me about. Jolly good. And let's just add a little bit. Remember, it's not clean. Here we see it's cloudy, but there's definitely some reaction going on there. Some of it seems to be either dissolving or reacting. It's hard to tell the difference. And while we're just doing this, I want you to try and think of a way that we could tell the difference between the calcium acetate and the calcium oxide. So we'll put one more in, then we'll mix it up. Now there's a lot of stuff that isn't dissolving, which is a good sign because it's telling me there's lots of calcium carbonate there. So we've actually taken our calcium acetate and converted it back into calcium carbonate just by heating it. And there's little black particles as well which are present, and that's going to be that carbon we were talking about. Now one of the things that we can do to see if we had calcium oxide is that when we added that to water, it would have given us calcium hydroxide, which is a base. And so if we test the pH of this solution and it's basic, we know that we will have had some calcium oxide present. So let's get a little bit of red cabbage indicator, and if you want to know how to make this red cabbage indicator, I have put a video up on it. It's a lovely indicator, though a little bit smelly because it smells of cabbage. And we'll just put a little bit in here, and you can see it's a lovely deep purple. Now I have to say the colour change to a base isn't too great. It's from purpley to sort of blue, so I want to get that right in the middle so we can see that clearly. And we'll add a little bit of this solution here. Just stir it up a bit more and see if it goes a bit bluey. It will also go cloudy because this mixture's a bit cloudy. But let's have a look, shall we? Did you see? Did you see it go a bit blue? There, can you see it's blue? It's a bit hard to tell. So I actually realised it's a lot easier to see the difference in the colours if I put them in test tubes. So on this side we've got the neutral indicator, that's just the red cabbage indicator. And on this side you can see that much more sort of lilac bluey colour is from our reaction mixture. So we definitely had the calcium oxide present because we've got a base in there, calcium hydroxide. So we've got base present, which is the calcium hydroxide. So not only did we convert some of the calcium acetate to calcium carbonate, we converted it also to calcium oxide. So we took our acetate, and because we converted it to calcium oxide, we can probably assume that there isn't any calcium acetate left in here because it took such a high temperature to go to calcium oxide. So I would say this is a mixture of calcium carbonate, calcium oxide, and deposits of carbon to be grey. So we've been able to analyse this mixture just by using our observations and also by using a little bit of scientific knowledge about pH. I was just taking a bit of red cabbage. I thought it would be useful to have a look at the reactions that we've explored with calcium. So we started off with calcium carbonate, and you can see the molecular formula is below the name, and we added acetic acid. or vinegar. And when we added that, well, the carbonate on calcium carbonate reacted, and we had carbon dioxide given off, that was a gas. We also had two of the hydrogens from two different acetic acid molecules reacting with that spare oxygen to give us water. And then those deprotonated acetic acid molecules, they were then acetates, coordinated to the calcium. So we got calcium acetate. And if we heat that up, we put a bit of heat into it, well, it gives off something called acetone. But we get back to our calcium carbonate. That's what we've seen today. But if we put a lot more heat into it, and we keep heating it, we can make calcium oxide. And of course we'll have to lose carbon dioxide from the calcium carbonate when we do that. Now we saw something else today. We saw when we made a base by adding calcium oxide to water. And that was because we got something called calcium hydroxide, a base. And in fact, if we bubble carbon dioxide through that, we can get back to calcium carbonate. So you can see this really nice little cycle showing how all these reactions can be related to each other and how we can move between these different molecules. And it's really interesting as well, if you've heard about cement and concrete, that these reactions are really important in that process, especially the ones on the left, where calcium hydroxide is in the cement mix, and over time, as that cement mix sets and ages, it goes through a process called carbonation, and that's as it takes in carbon dioxide from the atmosphere, and those calcium hydroxide molecules get converted to calcium carbonate molecules, and it makes the concrete stronger. So I hope these little cycles were useful, and they're a really helpful way of mapping reactions. Thank you for watching. I hope that gave a bit of insight into how we can look at the chemical properties of a mixture, and that also things aren't always nice and clean and pure when we carry out a reaction. Now, I do hope in the future to do a nice sort of history of calcium and how it's influenced humanity. But I have to say, I haven't started making a video yet, and it's going to be a long one. So stay tuned, but don't think it's coming out next week. Thanks so much for watching. If you like our stuff, please feel free to subscribe, and I will have put some videos up somewhere this side or this side, which will be to do with the calcium work. Thank you so much, and see you next time.